Hope you all had a wonderful weekend. So, boys, you're going to pull your notes books out, the ones that I print off for you. Okay, today we are talking about matrix multiplication. So we've done what we saw with a brief intro to matrices. They're pretty straightforward to add together. They're pretty straightforward to subtract. We have scalar multiplication of them. What we're going to look at today is when we want to multiply one matrix by another. And the physical significance of it is not so important to us right now, and even ever, but it's just a good skill for us to touch on as we segue into the principle of mathematical induction. So, we've got these three matrices up here, all right, and below it I've listed the order. Remember, the order of the matrix tells you the number of rows, m, we use m for rows, and by the number of columns, n. So here we've got 1 row, 3 columns, okay? If you get them confused, think of the Greek pantheon, with these big columns, all right, columns going straight up. Okay, here we have 2 rows and 3 columns, and 3 rows and 2 columns. So we're going to start over here. We're going to multiply matrix A by matrix B. Now, before we're going to multiply the matrices, we're going to write down the order. So what we have is we have matrix A, which is a 1 by 3, and we're going to multiply that by matrix B, which is a 2 by 3. Okay, so we've got the matrix A, matrix B. Now, we can only multiply the matrices together if these numbers are the same. Okay, so in our first circumstance, these numbers are not the same, and so there is no solution to matrix A times matrix B. Okay, so there won't always be a solution. The number of rows by columns? The number of columns of the first matrix has to equal the number of rows of the second matrix. Very good. Then let's move on to AC. A times C, so we have a 1 row by 3 columns, and we're going to multiply that by 3 rows by 2 columns. So we check to see if we can perform this multiplication. Are these two numbers the same? Yes, they are. Okay, yes they are. But it also tells us something else. So yes, we can perform the multiplication. This here, 1 by 2, okay, that 1 and that 2, that tells you the order of the matrix that this product is going to generate. So it's going to have 1 row and 2 columns. It's going to have 1 cell here and 1 cell here, 2 elements. Okay, 1 row, 2 columns. And the way we're doing it, you can think this is the first row times the first column, and this is, I'm going to draw that up here so that we can refer to it, and the first row times the second column. Okay, you think of the location of this cell. First row, first column, still in the first row, second column. So, let's perform it. Here we're going to do everything in the first row times everything in the first column. Okay, so watch this. We're going to go 1 times 5 plus 4 times 2 plus 2 times 3. Okay, so I'm doing the first element times the first element, the second element times the second element, and the third element times the third element. Okay? All of the first row times all of the first column. Okay? I'm going to make this a bit bigger. So that's our first element, then we're on to our second element. And in our second element, we have the first row times the second column. So we're going, here's the first row, and we're multiplying it by the second column. So we're going 1 times 2, we're going plus 4 times 2, and then plus 2 times 3. Okay, and then we'll simplify that. Here we're going to have 5 and 8, 13, and 6, 19. And here we've got 2, and 8, 10, and 6, 16. Okay, so if we multiply matrix A by matrix C, we get matrix AC, which has 1 row, 2 columns, and these are the values that it takes. Very good. Let's move on to matrix, what's next on our list? I've got BC written up there, but I think...
Yeah, BC, isn't it?
BC, very good. So this is matrix B times matrix C. So I've got them written up here, right? We can see that the number of columns of the first matrix is equal to the number of rows of the second matrix, okay? We've got 3 and 3, and the resultant matrix is going to have 2 rows and 2 columns. Okay, so it's going to be a square matrix with 4 elements. Okay, so how am I filling that in? First row times first column, first row times second column, second row times first column, and second row times second column. That's just describing the positional. Okay? So let's perform this multiplication. So, first row times the first column. We're going to have 4 times 5. Okay, plus 3 times 2 plus 1 times 3. Okay, so first row times the first column. We've done the first set. Let's move on to the second one. We have the first row times the second column. 1, 2. First row times the second column. We're going to have 4 times 2. Okay, so 4 times 2 plus 3 times 2. And then plus 1 times 3. Okay, in the next one, now if you're a bit stuck, don't worry. We can keep going over this because this, ultimately, it's pretty simple algorithm. Let's look at, so we've done that one. We did the first row times the second one. Here, this tells us, we've just filled it in, it tells us how we're going to construct this cell here. We need to do the second row times the first column. So we look, here's our second row of the first matrix times the first column of our second matrix. So everything in this cell, in this row, times everything in this column. We're going 6 times 5. Okay, so the first elements multiply one another. And 5 times 2. And then 2 times 3. Okay, and then for the last, we're doing the second row. We've got 2 and 2. The second row times the second column. So we've got 6 times 2 plus 5 times 2 plus 2 times 3. Okay, and let's simplify that. We're going to have, what do we got? 26, 9, 29, 8, 14, 17, 30, 46, 12, 22, and 8. Very good. See if I can get Vivi working. Yeah, I think I need to update it. Okay, so what I'll do then is I'm going to give you some calculated instructions, but I'm not going to be able to project it, so I'm just going to have to describe it to you and talk to you guys through it. So let's get our calculators out and form the rest of them. Now this is in the same setting that we did our vector calculations. Okay, so we're going to go into run matrix. I'm going to clear this off and put some solution steps up here. Show you what buttons to press. Oh yeah, how do we do it? Okay, the first button you press, you should be back to the main menu. You've got jump, delete, map/vector, and math. So we're going into that one, map/vector. Okay, that's the first button we're going to press. And we want it to be set on matrices. Okay, so F6 at the bottom switches between matrices and vectors. Okay, so if it's on vectors, if it says VCT, that's on vectors, you need to change it to matrices by pressing F6. Okay, that button in the corner. And then we can construct all of these matrices. We can construct matrix A, matrix B, and matrix C. So matrix A is 1 row, 3 columns. So you just hop onto it and you just start typing 1 and then 3. 1, enter, and 3. And then we can input all of the numbers. Okay, so let's do that for all of the matrices. Put in matrix A, matrix B, matrix C. Anyone stuck? Sophie? Brett?
Yeah.
That one, mate. There you go.
Yep.
Yep. You don't have the vectors 1, 1, 1, 2, Okay, so the next one's 2 by 3. And it's 4, 3, 1, 6, 5, 2. And then we have 3 by 2. Okay, anybody start? Okay, excellent. So we've typed in 3 matrices there. Okay, and then the way we're going to perform the operations is we go option mat/virt mat. Okay, and then what we want to do, what are we asked to do next? We've done AB, we've done AC, we've done BC. We need to find matrix BA. Let's show you what happens when it can't generate a solution for it. So we're going to type in mat, and then you press alpha B times mat alpha A. Okay, so A and B, maybe you've typed in some secret messages in your calculator before, you just bring them up using that technique. So mat alpha B times mat alpha A. Dimension error. Yeah, so you've got it there. Well, yeah, you've got to input all the matrices first. Dimension error, good. Dimension error.
Let's try. It's because, 2 by 3 and 3, 3 and 1. Yeah, actually different. It's quite unique, 3 and 1.
Okay, you guys follow along with that?
Let's try one that CA, doesn't work.
No, press X.
Let's do B.
Yep. So you're in matrices, that's why. Let's go matrices.
29, 17, 46. Yes, that's awesome.
We've got no, so for matrix, what was that one? That was BA. For matrix BA, no solution. Okay, so how about matrix CA? Okay, so we can type that one in. Matrix alpha C times matrix alpha A. Dimension error again. Let's check our answer then to one of the ones that we've done. So let's check our answer to BC. Let's type in matrix alpha B times matrix alpha C.
So that is
29, 17, 46, and 28. Good skills.
just go the across arrow when you're on.
Okay, so there's one point I need to make. So we've got those calculator skills. Maybe we need to practice the manual technique a little bit. It's up to you. But the other thing I just want to point out, because we don't have any questions around it, Rube and Paddy, is about the identity matrix. So an identity matrix is a square matrix. Okay, it could be, so if it's a square matrix, that means the number of rows is equal to the number of columns. So it's either going to be 1 by 1, or it's going to be 2 by 2, or 3 by 3. The number of rows has to equal the number of columns. It's square. If it's square, okay, let's just say it can keep going on forever. Okay, so you can have an infinite number of rows, an infinite number of columns. But an identity matrix just has ones going down the diagonal, and every other cell is a 0. Okay? So it doesn't matter how far it goes that way. But the point of an identity matrix is that if you multiply an identity matrix by any other square matrix, it will always get itself again. So it's got written there, you know, look at the bottom example. If you have A times I, it's always going to equal A. A times I equals A. So an identity matrix is a property of a matrix where you multiply it, it gets itself. It's like multiplying the matrix by 1, is a way of thinking of it. Okay, so just touching on that because there will be some questions that pop up about that. It's up to you whether you'd like to have a go at developing that manual algorithm skill or whether you want to use your calculator. We're just working on 5C1, 5C2 today. Let's get into it.